Yes, they completed it.
But here we are going to start the first chapter. Okay.
So can you do
Some
chapter
basic
2?
concepts of chemistry.
Okay.
Chapter 2.
Yes, can you do chapter 2?
The structure of atom, right?
Yes.
Yes. Then let's just start the structure of atom. So I'm going to ask you some questions from the structure of atom, or we are going to start from very basic. The first is basically representation of an element. Representation of an element. Let's say this is an element X. Then we symbolize or we denote, we write Z here and A here. Are you aware of Z and A? What is Z and what is A? Z is basically atomic number and A is mass number. So do you know how to calculate number of electron, proton, atomic number and mass number if a representation of an element is given?
Yes.
Yes or no? Okay. So I'm just going to ask you a question that calcium 20 and 40 here. Can you tell me the atomic number, mass number, number of neutron, number of proton, as well as number of electron? Can you tell me all of this?
Is that atomic number 19? No, 20.
What you just said? 20
Is
is
that
what?
atomic number 20?
Atomic number 20, yes. Yes, atomic number 20. Can you tell me the mass number?
I don't know mass. Oh yes, 40.
You don't know mass? 40. Can you tell me the number of neutron? Do you know what is neutron? And where does it present in an atom?
In the nucleus?
Nucleus. Very good. So please let me know the number of neutron in this atom.
1.
Not 1. See how we are going to calculate all of this. So first of all, you have to remember some points like this atomic number is always equal to number of proton. It will be always equal to number of proton P, and it will be also equal to number of electron in neutral atom. In neutral atom. Why we say in neutral atom? Because when reactions takes place, electron can be lost or gained. When reactions takes place, basically I want to say that electron can be lost or gained according to the situation. So electron can be lesser or more, but proton is fixed. Proton will always be equal to this, not it, wait a minute, Z. Proton will always be equal to atomic number. So from this point, if you want to calculate number of proton, it will be equal to atomic number. So number of proton will be 20. Now come to this point, electron. If there is charge on atom, that means it is not neutral, uncharged. But if it is neutral, that we can see on Ca, calcium, there is no charge. In this case, number of electron will be number of electron will be equal to atomic numbers. That's why the number of electron will be 20. Are you getting my point, Maha?
Yes.
Now come to this point, n. N is basically number of neutron. And how we are going to calculate number of neutron? So basically there is a formula, mass number, that we denote it by A. mass number is equal to number of neutron plus number of proton, or you can write mass is equal to number of proton plus Z, because number of proton and atomic number are equal. So from this representation, we know that A, atomic mass is, mass number is 40. So I'm going to just put the value 40 will be equal to, we need to calculate number of neutron. So N, and what is the value of P? We just calculated, or Z, 20. So here number of neutron will be also equal to 20. Okay, so we get the value of number of neutron, that is 20.
Okay.
So please write all this. This is our basically trial class. So I'm going to talk only about basics. And if you have any doubt in any of the two chapters, first and second, you can ask me.
Okay, sir. Okay, done, sir.
Yeah. So this is very easy. You just need to remember that there is a formula. Mass number is equal to number of neutron plus proton, or you can write number of neutron plus atomic number. And also atomic number will be equal to number of proton and electron in neutral state, in neutral state only. Now I'm going to give you a question, S16, and here it is 32 and minus 2 it is. Can you tell me the number of neutron, proton, atomic number, mass number, and electron?
Neutron is 6, proton is 16.
This is 16. What? Can you repeat it, please?
Proton is 16.
Atomic number is 16, right?
Yes.
Okay. What about mass number?
Minus 2. No. Okay.
No. This is 32. I just wrote mass number here instead of here because there is a charge on this atom, that's why only. Okay. So mass number can be written on the left or right according to our convenience. Okay. But it will be on top. Okay. So mass number will be 32. Okay. Can you tell me the number of proton?
16.
16. Can you tell me the number of electron and neutron?
Is it minus 2?
Not minus 2. What you just said about, is it about electron or neutron?
Electron.
Electron, not minus 2. Okay, let me know the number of neutron first. Then I will explain how to calculate number of electron. Just write the formula, this formula. You can use this formula to calculate.
Okay.
Yeah.
Is it 16?
Yes, it is 60. Now see, what is number of electron? See, the number of electron will be equal to proton in neutral state. In neutral state, but here it is written that -2. Do you know that when an element gains electron, which type of charges it will have, positive or negative?
Have negative.
Negative charge. If there is an atom that is X minus, that means it gained one electron. Yes or no?
Yes.
Gained one electron. But when we talk about X minus 2, that means it gained two electron. Yes or no?
Yes.
So basically, in neutral state, electron must be 16 electron, but it gains 2 electron. That means two more electrons are of electron will be 18. Are you getting my point?
Yes.
Now tell me, an element is there is a Y element, and if it has one plus charge, that means it loses electrons. And how many electrons it lost?
1.
One. One electron lost. That's very good. And if an element have plus 3 charge, that means it loses 3 electron, right?
Yes.
Very good. Now moving to the next question. That is Na plus 11, 20. Z, A, E, P, N.
Z is 11.
Yes.
A is 23.
Very good.
P is 11.
Very good.
N is 12.
Very good. What about electron?
12.
12. How did you calculate? It already has. If it is in neutral state, it has 11 electrons, but it is positive plus. That means it loses one electron. So the electron it will have. Wait a minute. So the electrons it will have will be 10 now.
Oh, okay. Yeah.
Because it loses one electron, so the number of electron will be 10. Yes or no?
Yes.
Again, Z, A, E. So you have completed covered the full chapter, second chapter, the structure of atom.
Yes.
So it's periodic table that is going on in your school.
Yes.
Okay, that's very good.
Z is 13.
Good. A
is 27.
Very good.
Electron is 10.
Very good.
P is 13.
And N is
minus 14.
Very good, very good. Now that means this is clear with you. Is there any doubt in this?
No.
Okay, last question. Then we will move to the next. Z, A, E, P. This is the basic of this chapter. After this, I am going to start electromagnetic waves that will be related to wave.
Okay.
And very important.
Z is 15.
Z is 15.
A is 31.
15, A is 31.
Electron is 12. Electron is 12.
That is wrong answer. At least you should
Oh.
see the charge.
18.
Plus 3, that means it loses to 3 electrons. Minus 3, that means it gained 3 electrons.
18.
18 it will be. P is
Proton is
15.
15.
And neutron is 16. Will it be 16?
No. To be 15.
Neutron is 15. Now see, apply the formula A is equal to N plus P. A has a value that is 31 and we need to calculate N, and P is 15. So N will be equal to 31 minus 15. That will be equal to 16. Na?
Oh, yes, 16. Calculation mistake.
Very good. Now see, we have basically electromagnetic waves. EMW, electromagnetic waves. This will be useful when we will study Bohr's theory, because they consider that basically electron possess two types of nature, particle nature and wave nature. That's why we need to study about wave nature, particles nature and wave nature. So we need to study about wave nature. So basically, first of all, or you can write radiant energy. Now see, always remember that the speed of electromagnetic waves is equal to the speed of light in air or vacuum. Light in air. So what is the speed of this? 3 into 10 raised to the power 8 meter per second. You have studied about this, that the speed of light in air or vacuum is almost equals to 3 into 10 raised to the power 8 meter per second. Is that clear?
Yes.
Now there are some terms which are very important to wave. I'm going to draw a wave like a structure like this. And in this, you have already studied in your previous classes that this is crest, this is crest, this is also crest, and the downward, this is trough, this is trough, this is also trough. Now see, we have some terms like wavelength, wave number, velocity, frequency, time period. All these terms we need to clear what is this according to this wave. So always remember that the distance between two nearest crest or the distance between two nearest trough is called wavelength. What is wavelength? Wavelength is basically denoted by this, and this is called lambda. Do you know? This is called lambda. Its name is lambda. So how we are going to define lambda is the distance between two, either you can take nearest crest or you can take nearest trough, is called wavelength. Since it is distance, its SI unit is meter. Its SI unit is meter. Other units can also be used according to our requirement, centimeter, kilometer. But generally we will use the unit meter or centimeter. It is also very important to learn that, and you have already learned in the first chapter that, do you know in 1 nanometer, how many meters are there?
Oh, I don't know.
In 1 centimeter, we know that in 1 centimeter, 10 raised to the power minus 2, it's 10 raised to the power minus 9 meter. Because whenever there will be calculation or numericals in this chapter, when there will be numerical in this chapter, there will be wavelength in terms of nanometer, angstrom, picometer. These terms will be used. So 1 angstrom is equal to 10 raised to the power minus 10 meter, and 1 picometer is equal to 10 raised to the power minus 12 meter. Also to the power minus 6 meter. So question on this electromagnetic waves will be asked in terms of micrometers. 1 Fermi meter will be equal to 10. Am I audible,
Yes.
Maha?
Yes, sir.
So what I was saying is it's about wavelength. Distance between two nearest crest or trough is called wavelength, and the questions of wavelength will be in term of nanometer, angstrom, picometer, micrometer. So we need to learn how to convert this. So I just wrote all this. 1 nanometer will be equal to 10 raised to the power minus 9 meter, angstrom, picometer, and micrometer, and all this. Please write it.
Yeah, done.
Very good. Now see, wavelength. After wavelength, there is the second term, that is nu bar. Basically, it is wave number. Wave number nu bar. So it is basically, it is reciprocal of wavelength. It is reciprocal of wavelength. Nu bar is equal to basically 1 by lambda according to the definition. So you can also calculate SI unit will be basically meter, but there are other units like centimeter can also be used. So this is wave number, wave number, and then third comes frequency. What is frequency? So see what is frequency. Frequency is denoted by nu. This is nu bar, and this is nu. So what is frequency? See, if you are going to walk in a circular park, so basically what is frequency? In 1 second, how many distance you have covered of that circular park is called frequency. If you are going to define it in the form of wave, so basically wave passed through a point, through a point in 1 second. In 1 second, that is called frequency. It is defined for 1 second. That for a given point, how many waves are passing in 1 second? That is called frequency, and its unit is basically hertz. Its unit is hertz. Nowadays, we also use per second or per second, and its old unit is cycle per second. What it is? Cycle per second. Please write it. Now I'm going to give you a question. Calculate wave number of yellow radiation having wavelength equals to 400 nanometers. So wavelength is given, we need to calculate wave number. Can you do this?
Yes. So do I have to convert the units of?
See, 1 nanometer, yes, it's converted into nanometer. Okay. You asked about unit, right, Maha?
Yes, sir.
Okay. What do you want to ask about unit?
Do I have to convert the 400 nanometer?
Into meter, yes, convert it into nanometer.
Okay. Is it 0.25 into 10 raised to 7?
Just let me check. 400 nanometer into meter, if you are going to convert it, this is 400 nanometer. So it will be 400 into 10 raised to the power minus 9 meter. And if you are going to convert it again, 4 into 10 raised to the power minus 7 meter. So basically, now we need to calculate nu bar. Nu bar, that is equal to 1 by lambda. So basically 1 by 4 into 10 raised to the power minus 7. Very good. Now it will be 1 by 4 into 10 raised to the power 7 per meter. What will be the unit? Per meter, because here it will be meter. So that's why. And 0.25 into 10 raised to the power plus 7 per meter. Is that your